a squared, b squared, c squared, 2bc cosine. Okay, and then we start filling in the y's. 23 squared, 28 squared, minus 2, 23, 28, cosine 103. And then square root it, and what'd you get? 48? 40.03? Thank you, guys. So little a, 40.03. Now, you have an angle and a side opposite, so you drop the lot signs. And this one's forcing you to find angle C next.
I'm still trying to think which you use.
What's that?
I'm trying to think which you use, like you know how you find the side? Like you know how I said you can use it.
Yeah, laws. I've got a couple more problems here in a minute that'll show you why this comes about. Okay.
What happens if you don't solve your biggest angle first?
With this problem, nothing, because you're given angles obtuse.
But it will matter for the sides outside.
Yes.
Okay.
There's, I don't remember what day I talked about this, but what happens in Algebra 2 is you get what's called an ambiguous case of the law of sines. Sine values is from 0 to 180. Sine of an angle is the y coordinate here. The y coordinate here is the same because they're both, the y values are both positive in the first, second quadrant. So what happens is if this is a 30-degree angle, the 150-degree angle has the same sine value because they're what you call a reference angle. They're the same distance off the x-axis. So what happens is a 30-degree angle could also occur with a 150-degree angle, and sometimes if the other side lengths match, you can wind up with multiple triangles. By finding the largest angle first, you usually find an obtuse angle, which means you don't have to worry about the possibility of a secondary triangle. It's nothing more than prepping you just to remember always find the biggest angle first. To remember that when you get to Algebra 2, because then you get into this crazy thing called ambiguous case, which is a pain in the butt. Trust me, when you get to it, and if your teacher doesn't show you my shortcut, come to me and I'll show you the shortcut. It's awesome. Okay. So anyway, back to this one. Then we have sine of C is to 28. We all know that we got to multiply by the 28. So if you wanted to start writing that there and not worry about it, then you know how to type that straight in. Okay. So if I go to my calculator, fraction bar 28 sine 103. Nope, I am not at that spot there. Let's try that again. Fraction bar 28. Yeah. Sine 103 over 40. And then inverse sine 42.96 for the angle. And now you have 2 out of the 3.
Subtract all of that, you get 34.
Sounds good to me.
What about that?
What about? What do you have to find first?
You define the corner.
Which corner? You're right. You got a 1 in 3 chance now.
A is the biggest one.
Biggest one, good. So if you flip it over, that's this. The back side is the one that was the trickiest value. I think I went A, B, C. I went to B to the right, didn't I? Did I go up top? I guess it doesn't really matter. So help me out. Was it 14, 10, 19? 14,
10, 19.
Okay. Now, in this scenario, we need to find the largest angle first. Whenever you have law of cosines and you don't have an angle, you only have sides, you always use the largest angle first, which means I got to find A. So again, just like we did earlier, we write out our formula in terms of A. A squared is B squared, C squared, 2BC cosine A. All right. Fill in the blanks. Remember, break this down into smaller chunks. 19 squared is 10 squared plus 14 squared minus 2 times 10 times 14. And then I have the cosine of A. Very good. 361. 396. No, 14. Yeah, 296. Sorry, thank you. 296, and then it's minus 280. Okay. Now you're in a 3-step, excuse me. What do you have to move first? Not divided. Subtract. So you subtract the 296. Okay. When you subtract the 296, is that 30, 39, 65? Sound good? So we have 65 is negative 280 cosine A. How do I move the negative 280? That's where you divide. Yep. Remember, you can't combine these two because one of them has a cosine, the other one doesn't. Like we said yesterday. Now, this is going to be your crummy fraction. Okay? This is going to be your crummy fraction, your crummy decimal that equals the cosine of an angle. So we just type it in and enter in do the inverse then. So you'll have 65 over negative 280. Hit enter. Crummy decimal, second, cosine, second, answer. And I get my obtuse angle. Okay? My obtuse angle. So now I have 103.42 for my angle A. 103.42. And now I have an angle at my side opposite. Which angle do I find next? C. Yep. The next bit. Exactly. So we have sine 103.42 is to 19 is, how much wrong was that? Sine of C is to 14, but since I normally have to multiply, I'm just going to put 14 over here right now just to help shortcut it. Then back to my calculator. 14 sine 103.42 over 19. Make sure you hit sine, not cosine. And 45.78. And then your last angle then, just subtract from 360 and you get it. 30.8. Oh, point, I'm sorry, I thought you said point. Sorry, yeah, thank you. Did I say 360?
Yeah.
Did I say 360?
That's why I said 360.
Huh. Good morning, everyone. I hope all is well. I'm having a little bit more coffee. Apparently, that's what's needed at this moment. I like coffee. I mean, as I have my coffee, you probably smell in your mind.
My hair started very heavy.
I'm well, but apparently I can't remember that triangles have 30. I was at 360 again. All right, so the question was asking earlier, where does this be able to get us to go to? What is this going to allow us to be able to do? It's going to allow us to do some really simple word problem stuff. So last week when we did elevation, guys, things, it's kind of the same concept, but now we're dealing with drawing different types of pictures. It's not any more difficult. We're still going to have formulas. We're still going to work through them. But it's a matter of how do you interpret information. Okay. We'll still be doing more of it because you got to mix them all together. Real quick, as you guys get this one, go ahead and cross off number 4 and cross off number 6. Those are. Oh, I'm sorry, Dave. I forgot you were over there. I saw you get up, and I forgot to. All right. So don't worry about 4 or number 6. They get a little bit more complicated than what we need to worry about with some duplicating angle of elevation style problems. For us, I'm trying to keep these things as simplistic as possible in terms of how do these pictures actually look. So let's see if we can try and draw a couple of these pictures together before I let you guys go. So let's look at number 1. Number 1, you have during a figure skating routine, Jackie and Peter. Oh, did I do? I'm sorry. Did anybody else just get a single-sided one by mistake? I'll trade you. Because this was the original that I printed out, and then I usually print them single-sided in case I need to do something, and I left it in. So during a figure skating routine, Jackie and Peter skate apart with an angle of 15 degrees between them. Jackie skates for 5 meters, Peter skates for 7. Aren't they? Well, that means we have to draw pictures, don't we?
What is that? That's ice skating.
What are they not? One is one of them skate. All right, so one's. Is that feasible? If this is what this could look like to start with?
Yeah.
I get the look of total disdain for Mr. Bond in the back. Then a few words, he just shakes his head at me. All right. So, all right. Then we'll say goodbye. I thought it was funny. So, I got you going. You okay?
I'm good.
You sure?
Yes.
Okay. Did you want to see the skaters together? I can bring it back.
Oh, I'm good.
You know, we can make them go wee. Anyway, so what happens is you've got two people skating. All right, they're starting at the same spot and they go away from one another. Where they're going away from one another, one goes one way, the other one goes another. The degree between the two of them is how much? 15. So their starting point, one person goes this way, the other person goes this way. The degree between here was 15 degrees. You okay with that?
Yeah.
So does it matter which person went what way? No. Okay.
We're trying to find out.
So if we say that Jackie went here, gentlemen, stop talking, please. Thank you. Jackie went that way, and Peter went the other way, just for putting letters in here. Now, how far did they skate? This way.
Jackie went 5.
5.
You gotta find 1, 2, 3.
Gotta find. So I gotta find this.
So then I say.
Now, let me get rid of it.
To the left 20.
So if we look at this, is this the law of sines or a law of cosines?
Cosine.
It's cosine, very good. This is a law of cosines problem. It's a law of cosines problem because you do not know the side opposite an angle. All right, so we have to use one of our 3 formulas. Now, the little bit of a downfall here now is we don't have A, B's, and C's, do we? We can make it though, can't we? Now, do we have any letter here for where they started? No. So if I make it really easy on myself, can I call this A? Which means this would be little a. So wouldn't I just use this formula here, but instead of the B's and C's, what am I going to use? The J and the P. Are we okay with that?
Yeah.
So we're going with that for the letter in there? All right. When you're adding this stuff together, does it matter the order in which you add things? No. When you multiply things, is the order which you multiply matter?
Oh,
No, and that's the thing with this. It honestly does not matter. So we would start it out, our a squared would be, we'll say j squared plus p squared minus 2jp and then cosine of big A. So we know j was 5, I'm sorry, j was 7, little j and little p. Honestly, it doesn't matter which one's which. It doesn't. It'll still work. So if I do 7 squared plus 5 squared minus 2 times 7 times 5 times the cosine of 15.
I noticed that like when we try to find
That's the whole pattern then. That's exactly what you're supposed to be doing.
I'm trying to figure out like how do you find the pattern?
Yep. Because it's forcing you to find a side opposite. Okay? It's forcing you to work with opposites and stuff. So we go over our calculator. Oops. It was 7 squared plus 5 squared minus 2 times 7 times 5 cosine 15. Now, this is a squared. What do I do to it? No, it's squared. I have to square root it. Okay? So how far apart are they? 2.53. They are 2.53 meters apart. Nope, because it's just asking you to find a specific piece. The word problems usually just asking for, but I don't think I have anything in here that breaks it into multiple pieces. Okay.
Is it telling me?
Right, and I mean, you can have a separate sheet there, right? It's not that big a deal. Let's see, 2. A bridge is supported by triangular braces. If each side of the brace has lengths of 63, 46, and 40, find the measure of the angle opposite the 46 side. Okay? And I know the answer isn't in your lap, so stop staring at your phone. Especially because you weren't around yesterday, this might be helpful to learn how to do what the heck you're learning. So, you have 3 sides of a triangle, don't you? Can you just draw a triangle? Do you have to have a bridge? No. Just draw a triangle. Fill in the side lengths. What angle, and then label it. Does it matter what you label it? No. Again, if you want to stick with the same scenario, if you're trying to find the side opposite, or so you can find the angle opposite the 46, wouldn't I call it maybe the little 46, maybe just call it little a? And go that route. And then the other two, B and C, doesn't matter, does it? So what I'm saying here is if I'm drawing this out, I'm just going to draw a triangle. And I had sides of 63, 46, 40. It wants me to find this angle here, so I'll just call that A, call that little, and the other ones don't matter. And now I just work it from there.
Yes, sir.
All right. Number 3, they give us half a mile. How many feet are in a mile? 5,280. So what's half of that? Yeah. 2,640. So instead of the 1/2 for number 3, write 2,640 feet. It's easier to work with instead of a fraction. Okay. Again, 2 observers are standing on the shore a half-mile apart, or this many feet. They're on the shore, they're across from one another. Is that a straight line? In theory? Okay. Now they see a boat out there somewhere. The angle from one person to the boat is 1 degree, the angle from another person is another degree. Doesn't that create a triangle again? Okay, so think about it. You have 2 people. There's A and B, and then we have to create some value of C here. How far apart were A and B again?
2648.
2648. How much?
2648. I mean,
I was gonna say, wait a second, that's more than a half a mile there, bud. And then it said the angle from A was what? The angle of B was what?
Angle A is 63, angle B.
Okay, and then what does it ask you to find? They're asking you to figure out this distance here, right? No, it just says the one. How far is it from there? Okay. So if you think about it, if you've got your 63. Oh, I'm sorry. Yes, so you would find both sides. So this one you might need an extra space. What's a good thing I said to skip number 4? So you can do the second part at the bottom there. Okay. Now here you have angle, side, angle. What are you going to use? Law of sines or law of cosines? Sines. Because you've got two angles, how do you find the third? Yep. Let's see. 5 is bad. To be honest with you, number 7 mirrors this one pretty much identically. Number 5. Do you guys know what it means by due south? Okay. So down, yeah, if you think of it that way. On a compass is this. So if it says that on a map, Orlando is 178 due south of Niagara Falls, well, this would be Niagara Falls.
You ever been there?
I have not. This would be Orlando. Okay. And then this is your distance. Okay. Denver is 273 from Orlando. Denver is 235 from Niagara, which means you have to figure out Denver. That's how you fill it in. So like I said, finish this one. I'll collect this one and your law of cosine sheet from yesterday. Oh, I'm sorry, not that one. I'm sorry. Finish this one. Then I have another law of sine cosine sheet that I'm collecting tomorrow. It has one of every possible style of solving. Whether you have to use law of sines form with side angle side, or side angle, or angle side angle. And then I have one of each of the possible ways of law of cosines as well. Mr. Bond, I think I gave an extra one back to you. Would you mind handing it over to David, please? The one's going back to you now. So, like I said, what we've got now here, guys, is the word problem 1. We've already done number 1 together. Height. I want you guys to fit. We've already set up number 2. We've already set up number 3. We've already drawn basically number 5. You have to draw your own on 7 to solve it out. Okay? So you're more than halfway done with those. On the sheet that I just gave back to you, you have 2 law of sines and 2 law of cosine problems. Okay? Now, I did not write the formulas on here. You probably want to make sure you have those handy to make sure you know what you're setting up and going. Quiz tomorrow, you'll have the formulas. I'll give you guys the formulas to set them all up. Okay? Now, the idea is, excuse me, by giving you guys, when I wrote these things out or made these things up real quick, this is each possible scenario for law of sines and law of cosines. When we did law of sines, we did it with angle, side, angle, just like this last one here, where you had to find the third angle and do law of sines to find the 2 sides. Then you had the side angle, where you had to find the missing angle first, subtract from 180 to find the other side. And then the 2 law of cosines were like the ones we have been doing, where you had the side opposite, where you had to find the angle. They're very straightforward. There should be no trickery involved at all. So you guys, when you come in tomorrow, you'll owe me 2 things. And we take our quiz and call it a week. We'll start circles on Monday.
Radius?
Yeah. What's that?
Radius?
We do talk about that, yes. All right. So we go from there, and then we'll go on. All right. Write down those formulas, get those on those sheets now, so you have them. So as you're walking around, or as you're doing them, when you've got time to start working, please do so. What's that? The circles, spheres do have radii as well, the multiple radius. A sphere is a 3-dimensional circle, as you get into it. Yep. We actually do a little bit of work with spheres when we do surface area and volume towards the end of the school year. They're super easy to work with in a roundabout way.
Why does just have like 4x4 problems?
Pretty much, something else. This should be really straightforward. Usually you guys see pretty well this one, so it's usually not much of a hassle. Pretty straightforward.